Hi, everybody. My name is Scott Sauber, and today I'm going to be talking to you about test-driven development with React, starting as a Padawan all the way up to being a Jedi. I have already posted these slides up on my blog, which is just my first and last name, scottsauber.com. And you can also follow me on Twitter at, again, my first and last name, just Scott Sauber there as well. So when I created this talk, I had a particular audience in mind, and those are React developers who are vaguely familiar with testing, but they're also interested in learning test-driven development. Now, while this talk will assume that you have previous React knowledge, almost all of these concepts translate to any front-end SPA framework that you might be using, no matter if it's React or something else, but all of the demos will assume that you have some React knowledge. We're going to cover all these different topics. We're going to talk about what is test-driven development, why should you care about it, what tools do I use when I do test-driven development, and what part of my React applications do I actually test. Also do a few different live demos, and you'll see test-driven development in action. My goals for you out of this talk is to learn two things. Learn the best practices, quote unquote, for writing React tests, which I use best practices in quotes and have an asterisk because these are just my opinions, and I'll likely change those opinions sometime in the future to some other way that I like better. And I hope to teach you how to test drive React code. So I hear a lot of times that, I can't TDD the front end, or I don't know how to TDD, or whatever the case may be. So hopefully seeing live examples of somebody test driving React will help teach you how you can apply that to your React applications. And we're going to go from this Padawan that we have here, this Padawan Obi-Wan Kenobi, all the way up to a Jedi Obi-Wan Kenobi by the end of this. So who am I? I'm the director of engineering at a software consulting company called Lean Techniques. We're based in Des Moines, Iowa, roughly around 100 people. And we focus on writing high quality test-driven code. I'm also co-organizer of the Iowa.NET user group. I've been writing React on and off for the last 6 years, all the way back in the days of React.create class and mixins and all that good stuff. If you're familiar with those, I'm a friend of Redgate and I blog as well. All right, let's just start diving right into it. So why do we even write tests, right? Like, why do we even do that? Well, we want to have confidence that our application actually works. So without these automated tests, what you have to do is you have to do all this manual verification, right? And the way I like to think about these things is when our tests are green or our CI pipeline is green, why aren't we deploying to production right then and there, right? Like, why are we letting it sit in lower environments and have somebody do some like manual verification, right? Like, why aren't we deploying that immediately production? What's stopping us? And usually it's some sort of manual verification or manual, manual tests that run against those environments or something like that. And instead of doing those manual steps, I'd rather move those to automated tests. So whatever it is that you're doing, go ahead and move those manual verifications out into automated tests and always just start deploying things to production. So that's really the mindset that I like to be in, and why I write tests is I want confidence that when everything's green, my application works. And conversely, when my tests are red, I want confidence that my application is actually broken. We'll talk a little bit more about that later. Another benefit of writing tests is we can document the behavior that we have through tests. So rather than relying on somebody to, remember all the different behavior of the application and have it just, up here in their heads, we want to document what that behavior is through our automated tests. So hopefully, you're bought into this idea of, automated tests, right? So then the question is, how do you do test-driven development? So people like to think of the whole red, green refactor steps, and we'll talk a little bit more about that in a second. But really the first step of test-driven development is to think, right? Think about what it is that you're trying to do. Think about what test code that you are about to write, like what makes the most sense as a first step. And then write a test that describes the behavior that you want to see. So for instance, if you have a feature that, like let's say you've got a form and one of those checkboxes is like, are you self-employed, right? Maybe when you check that box, another form field comes up like saying like, oh, how many years have you been self-employed, right? But that box saying how many years have you been self-employed only shows up when you check the box saying that you're self-employed. So literally, I would write a test that has that behavior. When I check that box, I expect to say I'm self-employed. I expect the one that says how many years have you been self-employed to show up. So again, testing the behavior that you want to see, and we'll dive more into what I mean by behavior here in a little bit, but that's essentially it, is the behavior that your application expects and that your users expect. And then run the test and watch it fail for the right reason. You would be surprised how many times you write a test that you expect to fail and it does not fail. Might be for a number of different reasons. Either your test setup is wrong and maybe it passes when it shouldn't, or maybe you wrote a little bit too much code the last time that handles too many scenarios, including the one you just wrote. But really running that test and making sure that it fails for the right reason. Some people who talk about test-driven development will say, hey, compiler failure is enough. But really for me, that's not enough. Like I want to be able to run the test and actually see it fail for the right reason, not just like be in an uncompiled state. Now, luckily, we're just going to be focused on JavaScript for this talk. But if you're doing TypeScript, I would not settle for a compiler error. I would actually make sure that it compiles and run the test to make sure it fails for the right reason. And then write enough code to make it pass. So sometimes I'll take the step that's like, I'm just going to hard code it in so that the test passes. And then, in a future step, I'll refactor that to handle more scenarios. But I don't always take that minimal step, right? So Kent Beck talks about this in his book, TDD by Example, where he talks about, sometimes he'll write, the silly code that's, just hard coding the value back so that the test passes. But a lot of times he'll write a little bit more code than that he knows he's going to have to write in the future. But then after you do that, after you make the test pass, then it's refactor time. So because you're in this green state where, hey, you wrote the test, it failed, and now you made it pass, you are safe to change one side of the equation or the other. You could either refactor the test to say like, oh, you know what, there's some duplication here. I want to go ahead and extract that out. And then after you do that, run the test again and make sure they still pass. Or you can go on the other side and say like, oh, maybe the implementation code, and maybe there's some duplication over there that you want to remove, or some better algorithm that you want to implement, whatever the case may be. You make that change and then run the test again, which it's safe to do because you're in this safe state where you have a green test that proves the behavior you want to see is still there and does in fact exist in your implementation code. We'll talk about that here in a second. You'll actually see some examples of that. But the key is don't change both at the same time. So don't change your test code and your implementation code without running a test in between, right? So change one, run the test, make sure you're still green, then change the other, run the test, make sure you're still green. Otherwise, when you start changing both at the same time, without making sure that you're green in the middle, something unforeseen could happen and you might lose the behavior that you were expecting. And then repeat this process. So go back through this process of think, write the test, see it fail, write the code to make it pass, refactor, and keep on this endless loop. So traditionally, people will say the term red, green, refactor, right? Where you're writing the test, see it fail, write the code to make it pass, then refactor and clean up the code. And then you're just in this endless cycle, endless loop of red, green, refactor, red, green, refactor, red, green, refactor. That really never ends. So why would you work like this? Why do test-driven development at all? Well, one benefit for me is it's a disciplined way of working. And it's a great way to focus because I'm just focused on the task at hand that I'm just trying to make that single test pass, right? I've been in a lot of situations in my career where like I start doing something, I'm kind of all over the place, and it feels like I'm like dropped in the middle of a jungle with a machete, and I'm just kind of like hacking my way through everything, and hope that at some point, I end up outside of the jungle and I get to the end of the jungle after hacking my machete enough times. But test-driven development for me is really a great way to make sure that I'm focused on the task at hand and that I'm getting constant feedback loop on whether my code or my design sucks, to be honest with you, right? So if something's really hard to test, that probably means that my code or my design of my code sucks, right? Because in general, like, let's say you have a 5-line function and a 1,000-line function, right? Like off the top of your head, guess which one's going to be harder for you to test? Probably the 1,000-line function, right? Not the 5-line function. So test-driven development for me is a really great way to get feedback on if my design sucks, because if something's hard to test, it probably means that it's hard to maintain as well. And test-driven development is a really great way to facilitate pair programming. So if you're in an environment where you're pair programming, that red-green refactor loop is really nice because, to start off a pair programming session, you can do what's called ping pong programming, where to start off, somebody writes a failing test, and then they hand over the driver's seat to the other person who makes the test pass, refactors, and then writes the next failing test. And then it goes back to the other person, and you just ping pong back and forth in this red-green refactor state. So I really like test-driven development as well for facilitating pair programming and making sure that everybody gets a chance to drive. And I find I don't spend hardly any time in the debugger at all, or like in JavaScript, like dropping console logs everywhere when I'm doing TDD. And I think that's because, I'm writing a little bit of code or a little bit of tests and then a little bit of code to make that test pass, right? So I'm very focused on the task at hand. So it's really obvious when I just have like a little implementation over here, what's going on, because I'm just focused on this little bit of code. I'm not writing code for hours and hours and hours and then come back and like, trying to test it and saying like, oh, one of these 100 lines that I wrote in the last hour isn't doing what I think. Okay, let me fire up the debugger or console logs and start spraying those everywhere. I just find I'm spending very little time in the debugger. Like, I've gone months without going into the debugger at all, to give you an idea. So that's another big reason, is like eliminating all the time I spent debugging locally is a big reason for doing test-driven development. But you notice, like, I didn't mention the tests really in hardly any of those first 5, like the regression tests that you get at the end of the day. But yeah, those are nice too, that because you get some confidence that you're not going to break things in the future. But to be honest, that's kind of just a bonus, right? All those other things I think are more important, like especially in the moment of why test-driven development is useful. But yeah, the regression tests that you get at the end of the day are also nice as well. So what is not test-driven development? So TDD is not a synonym for writing tests. A lot of times I'll talk to people and they say, oh yeah, we do test-driven development, but then you talk to them and really they're just talking about writing tests, not test-driven development where they're writing the test first. And TDD is not writing all of the tests up front. So just writing one test, making a pass, and then repeating that process over and over and over again. Not writing all of your test cases up front and then trying to make them pass one by one. And test-driven development does not mean you will never ship bugs. It does mean you will ship less, in my experience, but it does not mean you will never ship any bugs, because there will be things that you don't think about or requirements that come in that change or whatever the case may be. Test-driven development does not mean you will never have a bug ever, but it will mean you will have less in the future, in my experience. All right, so let's apply test-driven development to React then. So the first thing is, like, what tools are we going to use? So the two tools we're going to primary two tools that we're going to use are one tool called Jest and another one called React Testing Library, or at testing library / React. And we'll talk about why that's named that way here in a second. So Jest, many of you have probably heard of it. It's a test framework that has all sorts of stuff like being able to create a test, have assertions, all that kind of stuff. It prides itself on being a zero configuration testing framework where you can just get it up and going, and by default, it's kind of wired up for you. As mentioned, it's got an assertion library built in. You can do mocking with it, and Jest also hooks into Git as well. So it will be able to watch for any changes that you have made to your code since the last commit, and basically only run those tests that change. And it'll watch when you like make a change and save, and it'll automatically kick off your test. And we'll take a look at that here in a second. So I just did npx create React app to create a new React application. And by default, you'll get an app.spec.js. So how Jest works is it looks for anything that's got .spec.js or .test.js, and then it'll run those as test suites. And so here you can see at these two arrows, there's a test function that you can pass it. We're saying, hey, this is a test and here's the name I'm giving it. And then you have this anonymous function that is part of Jest. You can also, you may also see there's an it function as well. Those two are synonymous. They're just basically aliases for each other. It just kind of depends on whether you want your test to say test or it, which is usually followed by like should do something in the test name. And we'll take a look at that here in a second. And then on line 7 there, that expect is also coming from Jest, where that's the baked in assertion library that's built into Jest. So React testing library is the other package that we'll be using. So the npm package is actually called at testing library / React. There's also an equivalent for like Angular and Vue and some other SPA frameworks as well. But at testing library / React is the package that we'll be talking about. But that's kind of why they name it that, even though, if you hear somebody talking about it, they'll talk about it as React testing library. And it's just some utility functions for testing React. And they encourage behavior style tests. So React testing library tries to avoid testing implementation details as much as possible, and instead focuses on the behavior and not so much the structure of your code or how you implemented that behavior. React testing library gives you some ability to query the in-memory DOM, and some of those queries promote accessibility. So you can make sure that like a label is wired up to an input correctly. That way a screen reader knows what that input is for. And we'll take a look at that here in a second. And React testing library promotes something called deep rendering. So deep rendering is the opposite of shallow rendering, which shallow rendering means, let's say you have a parent component and a child component. With shallow rendering, you would only render the parent component's contents, not the child component's contents. So in shallow rendering case, it would just render as like, if a tag is called like child component, it'll just render a tag that says child component. Whereas with deep rendering, it will actually render the contents of that child component. So it'll not only render the parent component, but it'll also render the child component. And so coming from like a backend focus, unit test focus way, that kind of concerned me when I first heard it. Because I was used to more unit style testing where you are, testing this thing in isolation from all its other dependencies, right? And I used to do this with React with a tool called Enzyme instead of React testing library. But what I found is I was end up like shallow rendering didn't really give me much confidence that things were working. And especially on the front end, I think it's even more important that, these UI elements that you're clicking together work how you expect. And I haven't really felt the pain of the deep rendering like I thought I would, because I thought like, oh, I'm gonna have to worry about what all these different components are doing. But honestly, I haven't really felt that pain with React testing library at all. So that's been kind of a cool thing that, I'm getting the benefits of the confidence without the downsides of, having to know what all these different components are doing. And that causing a bunch of test bloat and stuff like that. So React Testing Library really promotes deep rendering and encourages those behavior style tests. So that's where lines 5 and 6 come in here on this, hello world example. That render function where it's rendering the app component that's coming from React Testing Library. And then you can see there on line 6 where it says screen.getByText. And I'm searching for the text learn React. And then on line 7, expecting that to be in the document. So that screen.getByText, that is a DOM query that's coming out of React Testing Library. So anything you want to do to integrate with the components rendering what the component rendered out, you would do screen.get by something like get by label text, get by text, get by role, whatever the case may be. And there's also query by text, find by text, and we'll talk about why you would use like the get by versus find by versus query by here in a little bit. But that's how you would interact with the DOM and be able to get those elements and then assert on those different elements is by rendering first and then interacting with it through screen. So let's go ahead and look at a quick demo of Jest and React Testing Library in action. So this is a straight out of the box, create React app application where I just did, npx create React app, and out of the box, you get this little full, file structure here. So I'm going to be looking at the app component, which is here on the right. You notice there's some just some hello worldy text saying like, hey, learn React, all that kind of stuff. And by default, you get this test right here. I'm going to go ahead and run npm test, which will run Jest. And something you'll notice here is it said that, hey, we ran this test and everything was good. So let's say I want to find the text, learn React, all exclamation points, right? I'll rerun the test here, and you notice that just automatically kicked off and reran that test just by me saving that file. And you notice it says, hey, there's a problem with screen.getByText here, and it's giving me a little red arrow as to what the problem is. And so React Testing Library is saying, hey, I was unable to find an element with the text learn React 3 exclamation points. This could be because the text was broken up. Or you can provide a text matcher to make your matcher more flexible. So this is where React Testing Library, when you call get by text and pass it a string, this is expecting the exact text. So if I go over here and hit save, so re-kick off the test, and you notice everything's good now. But let's say I lowercase this, right? If I save and rerun the test, this test. This string text here makes sure that your case is a case sensitive search. So you notice now I'm getting that error saying, I can't find learn React, right? So an overload to this is there is a regex matcher. So you can pass a regex expression to this as well. And because I'm doing an case insensitive search here, you notice now the test is passing. So I always try and default to using the string matcher as much as possible because I want to get that more specific error message, and it's just a little bit easier to read than this. But that's just something I see people get tripped up on all the time, is the fact that, that is a case sensitive search. But that just gives you an idea of how to interact a little bit with React Testing Library. If you look by all the different things that you can get by the text, the alt text, which is useful for images, label text for like form inputs with labels, display value, placeholder text, role, test ID is kind of like a last resort where you can put like a custom attribute data-test ID on a element, or you can grab it by the title, and that just gets an individual item. It doesn't necessarily get you all of the items. So one thing to note here too, is we talked a little bit about get by text versus query by text. So if I just instead over here, switch this back to, learn React, which it will fail because, this is lowercase and this is uppercase over here. And so you notice, where does it fail over here? Is it when I do query by text, it fails on the assertion this time. Whereas up here, I was failing on the get by. So this is an example of when to use query by versus get by. So get by will throw an exception, throw an error anytime it does not find the element, whereas query by does not. So query by is really nice for things where you want to say, hey, this should not be in the document, right? Because if you use that with get by, it's now in passing. If you use that with get by, it would throw an exception. So you'd have to do like a try catch and like all that kind of stuff. Query by is really nice for using it for like something not being on the screen. But you'll notice if I re-kick this off again, it doesn't really tell me anything other than, like, hey, you weren't in the document, right? Like all I got back was a null, so it wasn't in the document. But like, how do I debug this, right? It's really hard to debug because I don't even know what's on the screen. Whereas if I do a get by text, I want you to watch what happens when it throws that exception. So it throws the exception saying, hey, I couldn't find this, but then it echoes out all of the HTML that was here on the screen. So then I can go ahead and look through this and be like, oh, okay, there's my learn React. Oh, it's uppercase R, not a lowercase r. Let me go ahead and just switch that back, right? And then I can rerun the test and everything's good to go. So that gives you a little quick overview of when to use get by versus when to use query by. And we'll take a look at when we're going to use both here in a second. All right, so that was a quick overview of React testing library with Jest. So what should you test? We want to test behavior. And again, if I go back to that example of, having that checkbox, the self-employed checkbox, where when you check it, something shows up, that's the kind of thing that I would test. Or, you click submit, right? And assuming everything was good, you get a like confirmation saying, hey, this request was submitted successfully. I would assert that, that message showed up on a success. So that's the kind of thing that I would assert on. I would not assert that, CSS classes exist or really any other attributes directly exist, because those are more implementation details. And, test with React testing library doesn't give you confidence that your application looks okay. That's not really what it's solving. It's more testing the behavior of your application, not the look and feel of your application. So again, you're testing behavior. So the litmus test I have for this is if I can delete code that breaks your application, but your tests don't break, to me, that's a huge problem, right? And the inverse problem too is if your test breaks, but your application doesn't, that's also a problem, right? So if I can delete code that breaks your application, but your tests don't, that means you're missing a test, right? So there's some tests that you're missing that doesn't capture the behavior of your application. But for this one, where my tests break, but my application doesn't, that's a sign to me that, I'm not really testing the behavior of my application. I'm testing like the structure of my application or something like that, because the only reason why my test should be broken is if my application is broken. And I'm not a fan of snapshots in Jest. So I think let's just do a quick example here. So if I get elements from the render function, let's just go ahead and look at what I mean by snapshots. So with Jest, you can do this thing called toMatch snapshot. You notice it says, hey, one snapshot was written, right? So what snapshots are is now I have this __ snapshots folder with this app test.js snap file. And what a snapshot is it snapshots my entire DOM structure, right? And it stores that into the snap file. And so then when you call toMatch snapshot, it double checks to make sure that the structure of your application hasn't changed. So if I just do something as simple as like, let's say I'm just going to like, use a utility class to like add a margin top of 1 rem, right? It's going to yell at me saying like, hey, you don't match the snapshot. The difference is this, you have a new CSS class here, and, the snapshot didn't match, but do you want to press U to update the snapshot? So I'm going to be like, yep, I want to go ahead and update the snapshot, right? And then I'm back to green. So what I don't like about this is it doesn't capture the desired behavior of my application at all. Like it just tests my current structure of my application. as well as it's extremely tied to implementation details. So if I switch things from like a div tag to a main tag, or, vice versa, or, add a CSS class like I just did, or whatever the case may be, my snapshot's going to fail, even though, my application didn't change at all. So really, that's one of my beefs with snapshots. And that's why I don't use them 99% of the time, because they don't capture desired behavior. I do use snapshots when I'm doing an entire refactor of the component that I'm testing, but the output of that component should be the exact same. The HTML should be the exact same. And so when I'm doing a total refactor, I'll first write a test that asserts on that snapshot, creates that snapshot, and then I'll refactor all my code. And then but I'm only doing that if all of the HTML should be the exact same at the end of the day. And then after I assert that, hey, nothing changed with the output of the HTML, then I go ahead and delete the test. So I have confidence that I didn't break anything, but that test is just going to be a maintenance burden going forward, and I don't want it. So I'm going to throw that snapshot test away. And so this is like some lessons learned from using snapshots, because I used snapshots for a long time and just found more and more that they just cause friction with my test code and didn't actually really catch any problems that were going on. So that's why I don't use them anymore, except for that case where I'm doing a big refactor, but the output should be the same. So along the lines of what should you test, I really like this quote by Kent C. Dodds, who's the creator of React Testing Library. He said, "The more your tests resemble the way your software is used, the more confidence they can give you." So the more, that's part of the reason why he promotes the deep rendering in React Testing Library, is because that's more how your software is used, and therefore it's the more confidence it can give you. I really like this quote, and this is something that you should think about while you're writing tests, is like, hey, is my test resembling the way my software is used? Because if it's not, then it probably doesn't give me as much confidence as it could. All right, so how do I structure tests? So if you're familiar with Jest, you can have describes to kind of group different tests together. I never have more than 2 nested describes, 2 levels of describes, because I find more than that, it gets a little gnarly. I also avoid lots of before eaches in those nested describes, because it can be kind of hard to follow, like, okay, all of this setup code and all of this setup code plus the setup code in my test specifically. It can be hard to follow that. So I also avoid lots of before eaches in those nested describes. And I see this occasionally too, where people have like a top level describe for the component that you're testing. Really, you don't need that, because you already know what component you're testing based on the file name that you're in. So if you're testing, app.js, you're going to have an app.spec.js or app.test.js, right? And I'm also a big fan of putting tests next to the file that they're testing. So I see sometimes people have like a source folder and a test folder, and the test folder tries to mimic the folder structure of the source folder. And really, I just don't find a lot of value in that test structure, because I want high cohesion, which means I want things that are related together to be together, right? I don't find a lot of value in separating the test code from the implementation code, because I find that those things are already tightly coupled anyway. So that's where I want those 2 files right next to each other as much as possible. So that way it's easy to see what's going on. I don't have to duplicate these folder structures in both sides. All right, let's go ahead and jump over to some live coding of a live test-driven development example in React. All right, so we're back in our Hello World application over here. So we are going to create a to-do list application here, or component here real quick. So I'm going to go ahead and create this to-do list component, and I'm going to go ahead and create the to-do list.spec for this as well. And as part of this test, I'm going to go ahead and import React, and I'm going to go ahead and create this test over here. So the first test I'm going to create is with a to-do list. I want to be able to pass in some to-do list items and be able to display all of those on the screen in an unordered list. So I'm going to go ahead and say, should display all the to-do items, right? Go ahead and make my anonymous function here. And I'm going to bring in the render method coming from React testing library. So I'm going to go ahead and say at testing library / React. Go ahead and bring that in, and I'm going to render my to-do list. Right. So I don't have a to-do list component here, and this is where you get into some people who say TDD, where a failing test of like non-compiling is okay. I don't necessarily believe that to be the case. So I'm going to go ahead and create a component here, just called to-do list. And now I'm going to import that one in. So as part of this to-do list, I want to be able to, pass in a list of to-do list items and be able to display all of those to-do list items that I passed in on the screen. So I'm going to call this to-dos and give that an array and have an ID of 1 and a title of, let's say, grocery store, right? And I'm going to go ahead and duplicate that. And I'm going to have an ID of 2 and say, clean kitchen. Right, go ahead and save that, let Prettier do its thing. And I'm going to pass those to-dos into my component here. All right, so after I do that, I want to be able to make sure, so this is kind of like the arrange part of my test. This is the act part. And then I want to be able to assert that, these 2 items show up here. So I'm going to go ahead and do screen get by text. Screen doesn't show up here, and I'm not getting very nice help from WebStorm over here. And so I'm going to say, hey, make sure that grocery store is to be in the document, right? And I'm going to want the same thing for clean kitchen. I'm going to go ahead and save that. And I have not kicked off my npm test yet. So let me go ahead and do that here real quick. And when I do this, I should get an error saying, hey, I wasn't able to find an element with the text of grocery store, right? All right, perfect. So now if I split these across over here and take a look at this, I should be able to grab those to-do items. So let me grab my to-dos from props here, pull props over there. And I'm going to go ahead and return back an unordered list. And I'm going to map over my to-dos here and do to-do and return back an li, and I'll put the key with the to-do.id so I don't get React yelling at me. And then I'll drop in to-do.title right here. And I'll go ahead and save that. And let's see what happens. All right, perfect. My test now passes. All right, so what refactoring opportunities? So I wrote the test, got a failing test for the reason that I ran it, got the failing test for the reason that I thought, and then I implemented the minimum amount of code to make that pass, right? I could have done the true minimum amount of code and like literally hard coded in the word grocery store and clean kitchen, right? And so this is again going back to, I have the option to do the minimum that I need, but in the refactor step, then I can go ahead and clean some stuff up. So one opportunity for refactoring that I can see is, I've got grocery store repeated here twice and clean kitchen repeated here twice. So I could, extract out, grocery store and clean kitchen out to variables, and then use those variables, down here saying, hey, grab the grocery store title and the clean kitchen title, right? Go ahead and save. Rerun that, and notice the test still passes. But again, I just refactored the test code and then reran the test to make sure I'm still good. I didn't also refactor this one over here, right? So I could, if I don't want to destructure, let's say, I could just do, props.todos instead. That's something I could definitely do as well. But you know what? My test still passes, and I actually like the destructuring part out of that. So that's all the refactoring I'm going to do right now. I'm going to write the next test here. So let's say I'm, displaying stuff on the screen. And actually, while we're doing this, let's go ahead and run an npm start just so we can see the application running side by side with the test code. So let's just go ahead and get that kicked off here as well. Just run those two side by side. Don't really want too much real estate being taken up by the by that screen. And you notice it's showing the default app.js. So I'm just going to make a quick change over here, and I'm going to instead drop in my to-do list over here, drop in my to-dos, and I'm going to actually literally just copy pasta this over here and then bring in my to-dos and drop that into my page here real quick. All right, cool. So now we can see the application running alongside the tests. All right, so let's go ahead and write the second test. So the next feature, let's say we the product owner looks this over and is like, oh yeah, I really like how that looks, right? Like looks great. But I really want people to be able to search through their to-dos, right? And it's like, okay, no big deal. Should filter results when search text is typed. Let's just say that, right? So I'm going to go ahead and steal all of this code here. Normally I wouldn't do that, but in the interest of time, I'm going to just go ahead and copy this over. This is all going to be the exact same. Maybe there's a refactoring opportunity there. We'll worry about that here in a little bit. I don't really want to worry about that right now. But after I render this, I want to be able to grab the search input and say, hey, screen.getByLabelText, and search for the search, and then be able to say, user event.type. I want to be able to type into that search input and search for the word. Let's just search for grocery, right? I'll search for grocery as part of that. So I'm expecting the grocery store to be in the document, but I'm not expecting the clean kitchen to be in the document. You notice ESLint's yelling at me saying, hey, you should really use query by rather than get by here. Kind of like what we talked about earlier. So I'm going to go ahead and use query by and say, hey, the grocery store title should be in the document, but the clean kitchen one should not be. So just take a quick second and think about where this is going to fail. Is it going to fail here, or is it going to fail somewhere else? If you said somewhere else and you said line 36 here, you are correct. So where this failed was it couldn't find this search input by label text. So I'm going to go ahead and create that input here. So I'm going to go ahead and just make a empty React fragment here, and I'm going to go ahead and say, grab me the search text, and I'll create me some use state here with an empty search text. I'm going to need to go ahead and import that in. And what I'm going to do with this search text is I'm going to assign it to an input. So I'm going to create a value and assign it to search text, right? But then I need to be able to actually call this and change this, because right now when I'm typing in on the screen, nothing happens, right? So I'm going to go ahead and call on change and say handle search text changed. Go ahead and create a function here. And I'm going to say handle search text change. That's going to take in an event. And I'm going to call set search text on event.target.value, right? So that'll get me the actual value. And you notice now things are changing. Perfect. But I'm not actually filtering anything, right? So I still need to write the code for that. So I'm going to call this filtered to-dos is equal to to-dos.filter. And I'll take in my to-do and say, to-do.title includes search text, right? So that'll be my filter down to-dos, and I'll use that when I display this on the screen. So you notice now nothing's showing up. And, if I type G for grocery, then only the grocery store client shows up. And when I type capital C for clean kitchen, That's the only one that shows up. But you notice when I typed lowercase g, that didn't show anything. So that's something to keep in mind over here while I'm, that's something to keep in mind for our next test perhaps. But you notice I'm still failing on this test. And why is that? Like, my code works. Why am I failing, right? Well, it's saying, hey, I was unable to find a label with the text of search. And I might go like, oh, okay, cool. I just need to do this, right? Save that, rerun it, let the test rerun, and you notice I'm still failing. And so the reason why I'm failing is there's nothing associating this label with this input. And so React testing library is testing that, hey, your labels and your inputs are married up together, which is an accessibility concern, right? So like people who are on screen readers, they need to know that this element, the search element is tied to this input element. So I'm going to use an HTML4 and call this search text and, give this an ID of search text, right? To marry those two up. So now if we rerun this test here, everything should be good to go, right? So that was an example of how, React testing library is helping you out with your accessibility of your application, which is pretty cool. So it's not only testing the behavior, it's also making sure that you're creating an accessible application, which is pretty cool to me. So everything is all good now. I'm on the refactor phase, and I see a lot of duplication specifically in this right here, right? So I'm going to move that up for me, move that up and go ahead and delete it out of here as well and save and rerun this test suite. And you notice everything is still good to go. So I just eliminated some duplication there between my two pieces of test code here. But if you recall, when I was typing in earlier, I did lowercase g and I got no results. So unfortunately, my handle or my filter to dos here is not handling case insensitivity. Ooh, can't say that. So when the search case is case sensitive, I'm going to go ahead and rename this test to that. And I'm going to make another test that says search test, or when the search text is case insensitive. And so I'm going to change that to a lowercase g grocery. And so I should still get this grocery store in the document, but I still should not get the clean kitchen in the document because it doesn't have the letter G in it. So if I go look at my test, just to make sure it failed for the right reason, hey, it said it is unable to find an element with the text of grocery store. And you notice it gave me the line number that it was failing on. So then I can just do the simple thing and say 2 lowercase, 2 lowercase, rerun the test, and everything should be good to go, right? All my tests pass, just prove it, lowercase g. Now my application is, search is case insensitive, right? Well, let's say for some reason, I'm in the refactor step, right? Let's say, I don't love this running on every single, render, because maybe, this is an expensive operation. I only really want it to run when the correct things change. So I could totally do that using a use effect and say, hey, only run when the search text changes or when the to-dos change, right? And instead I could switch this to, have this be a use state, filter to-dos, use state, and have that start off going to my to-dos here. Now I'll go ahead and grab this code. Oops, I need a closing square bracket there. And then I want to call set filter to-dos and pass it in here. So instead of having this run on every single time there's a rendering change to this component, I only want this bit of code here to run when the search text changes or the to-dos change, right? In this example's case, technically those would be the only 2 times that would have ran anyway, but just work with me. I just did a refactoring in case, something changes in the future, or maybe I just like this pattern better, right? So if I go ahead and look at my tests, you notice everything still passes. And, if I start searching for things. I do ZZ, notice I don't get any results. Everything is behaving exactly how I thought it should. So this is really where the power of testing comes in, right? When we want to do a refactoring of how the code is structured without changing any of the behavior. So this is an example of how these tests were designed in a way that it captured the behavior that I'm looking for, not the fact that I was like, using a use effect or not, or, calling this function or not, or whatever the case may be. I was focused on the behavior of my application, not the implementation details. So that's really the power of React testing library in a nutshell, and combined with test-driven development, because I'm as new requirements come in, I'm capturing those requirements as tests throughout here. And obviously, like, we keep going on and on and on, but hopefully that gives you kind of a little look into how to test drive your React code. All right, so now that we've seen an example of doing test-driven development with React, a lot of people say like, okay, how do I get started with TDD? Or maybe, I'm not super confident in doing this on a new feature, right? So a super easy way to get started is, hey, when you get a new bug report coming in, write a failing test that proves that the bug exists, right? And then go make it pass. So this has two benefits. One, you get some practice doing test-driven development. And two, you prove that there was a problem and now you fix the problem. So another excuse I hear a lot is, oh, I don't have time to do tests or do TDD, right? And so I'll ask like, okay, why don't you have time to write tests? Oh, well, I don't have time to write tests because I'm busy putting out too many fires because we have too many bugs, because when we don't have tests that give us confidence that we're not breaking something, right? So you end up in this vicious cycle. Another excuse I hear a lot is my boss won't let me, right? My boss won't let me write tests, right? So what about this person, right? Let's say you go to some surgeon and say, hey, I need this operation done. And he's like, oh, okay, cool. It'll take 6 hours to perform this operation. And what if you said, oh, doc, sorry, I don't have 6 hours. How about you get it done in 2? Would you want to get surgery from the surgeon who told you, oh, okay, sure. Yeah, we can get it done in 2, right? Oh yeah, I can totally do that surgery in 2 hours. I just have to not wash my hand, not spend time washing my hands, not wash the tools from the last surgery. And I'll only use 5 stitches instead of the normal 50 stitches, right? That'll cut down the time, so I can do that in the time that you allotted, right? So you shouldn't be having to ask permission from anybody on how best to do your job, right? You should just be empowered and have the autonomy to do what you think is right for that situation. And some people will tell me also, oh, test-driven development is hard, right? And, I'm not going to lie to you. It can be hard to get into this mindset, and it will be hard at first, but you'll continue getting better and better at it. And you don't get better at test-driven development by not doing test-driven development, right? It's just like anything. You don't get better at anything by not doing that thing. You just need to keep getting more and more practice. So that's where, like the bug example, where anytime you get a bug report coming in, writing a test first that proves that it failed, proves that it's a problem, and then going ahead and fixing it and proves that you did fix the problem is a really great way to start. So some takeaways I hope you got from this. I hope you got why you should do test-driven development, how to test React, what to test in React, and then combining those two things together, TDD and testing in React, how to get started doing test-driven development with React. And hopefully now you've graduated from a Padawan onto being a Jedi Master Obi-Wan Kenobi. So some final resources for you. The TDD by Example book by Kent Beck. It's like 20 years old, but it's still my go-to reference for getting started in test-driven development. If you haven't checked out this book yet, I would highly recommend you do so. The examples are in Java, but honestly, you can translate what he's doing into any language, whether it's, JavaScript, C#, whatever the case may be. You can totally translate what he's doing, or just write it all in Java and follow along like what he does. I also like this blog post by Kent Dodds about writing tests and, the confidence that tests can give you. And you can also get this talk and the code from it at github.com/my first and last name/talks. All my talks are up there, so you can pull that down. And I intentionally kept this slide deck really detailed because I want you to be able to use this as a reference point and not have to rewatch this entire video. I want you to be able to go through the slide deck and kind of get the gist of what it was that I was saying just by glancing through and clicking through the slide deck real quick. So that's why I intentionally left the slide deck detailed enough that you could understand what I was saying. So if after you watch this, you still have some questions, feel free to reach out to me. My email is there on the screen. It's just ssauber@leantechniques.com, or you can hit me up on Twitter as well. Just, again, Scott Sauber. My DMs are open and happy to answer any questions that you might have. So with that, thanks for coming to this talk on test-driven development with React. Thanks, everybody.